Okay, video lesson number 7, covalent bonds. Now, covalent compounds form molecules, so they're also called molecular compounds. They are formed when nonmetal atoms share valence electrons to get 8 and complete the octet rule. Okay, most of the compounds that you're familiar with are covalent compounds. For example, water, which is H2O, carbon dioxide, CO2, those are covalent compounds. And actually, most of the compounds in nature are covalent. Okay, that would include things like DNA and protein as well. Okay, the attraction forces between molecules is relatively weak. Okay, so they don't form lattice structures. That means that they usually are gases or liquids at room temperature. And that also leads to the property of having lower melting and boiling points. All right, now the rules for covalent dot diagrams. Okay, so this is how you draw covalent compounds. Okay, number 1, we got to count the total number of valence electrons, which of course can be determined by looking at the group number on the periodic table. Remember, this cannot change. Number 2, we need to determine the number of bonds each atom makes. So you can do this by just drawing a quick Lewis dot structure. And of course, the unpaired electrons are the ones that can bond. So that will tell you the number of those, will tell you the number of bonds it makes. Step 3 is identify the central atom, which is simply the one that makes the most bonds. Okay, usually it's more to the left on the periodic table. And fourthly, and most importantly, every atom needs an octet. So we need 8 electrons around each atom, except hydrogen. Remember, a complete valence orbital for hydrogen is 2, so it looks like helium. Okay, let's do a couple examples. Okay, so our first example is CCl4, and while we're at it, let's go ahead and practice naming the covalent compounds. So remember the rules. We do the same idea. We name the atoms, carbon and chlorine, and then we modify the ending of the second one, so it would be carbon chloride. Then step 2 is to go back and add those prefixes in. So it would be carbon tetrachloride. Okay, so let's go ahead and draw this structure. So first thing is, remember rule number 1 is figure out the number of valence electrons. So carbon has 4 valence electrons, whereas chlorine, if I look at my periodic table, again, has 7. Okay, now 7, but there's 4 of them, so I got to do 7 times 4, which would be 28. So if I add that up, I've got 32 electrons to work with. Okay, now I need to determine how many bonds each atom makes. If I don't know already, a Lewis dot structure is helpful to see this. Carbon has 4 valence electrons. None of them pair up, so it's going to make 4 bonds, whereas chlorine has 7 valence electrons, and leaving 1 to make a bond. So chlorine makes 1 bond, carbon 4, so clearly carbon is the central atom. Okay, so I've identified my central atom. That was step number 3. Now I need to make sure all the atoms have 8 electrons as they form this compound. So you can maybe see what's going to happen here. See these electrons right? The only way chlorine's going to get 8 is if it shares one of those. Okay, and so if it does that, we would get something like this on this one side. Okay, and that would complete the octet for chlorine. Now maybe you can see the same thing would happen 3 more times on either side of the carbon. And so we can quickly just add the rest of them in. So making sure everybody's got 8. That is the key. Octet rule must be followed at all times. Okay, so now that I'm done, I want to visualize and make sure that that's the case. So if I look at chlorine, that one has 8, that one has 8, that one has 8, and that one has 8. So octet rule good for chlorine. What about carbon? Yes, carbon also has 8. You can see them right there. Now you don't have to draw these extra circles in there. I'm just showing you that everyone has 8. Now if I count on my total electrons, I got 2, 4, 6, 8, 8, 8, 8, 8 times 4, yes indeed, is 32 electrons. So I've done my structure correctly. Now if I was to make the models like we did in the lab, I would get something like this. Okay, and so when I have a central atom with 4 single bonds, the shape, remember that was important, we said was tetrahedral. All right, another example would be carbon or CO2 or carbon dioxide. How do we get the name? We've got carbon, we've got oxygen, we modified the ending of the second one, so we get carbon oxide, and then we have to add the prefixes in. So it's carbon, 2 is di, so it's carbon dioxide. Okay, so let's go ahead and draw the Lewis dot structure for this. So carbon again has 4 electrons. Oxygen, I look on my table, it has 6 valence electrons. Again, we're only looking at the valence electrons. But because there is 2 of them, it actually is going to have 12, right? So the oxygen's total, we got 12. So we add that up, that's going to be 16 total electrons to work with. How many bonds does carbon make? It looks like it's making 4. Oxygen, on the other hand, with its 6 valence electrons, looks like this. Oxygen can make 2 bonds with those 2 lone electrons. So the only way this is going to work is if oxygen gets 8 right here, and the only way that can happen is if it shares, for example, like these electrons, like that. If I was to do that, I would get something like this, where I now have 2 pairs of electrons between the carbon and the oxygen. Remember, that is a double bond. And then the opposite would happen on the other side. So, or the same thing would happen on the opposite side, I should say. So I get something like this. So this would be my structure right here. Okay? So that would be carbon dioxide. Now if I count my electrons, I've got to have 16, 2, 4, 6, 8, 10, 12, 14, 16. That's correct. Does everybody have 8? That's 8 right there. That oxygen has 8. And then you can see that the carbon also has 8. All right? Now, you can tell we got 2 double bonds going, so my molecule would actually look like this, and you built this one in the lab too. Again, it wouldn't be like this because those electrons repel each other, and so it pushes the molecule into its geometric shape because the electrons repel. So when I got 2 double bonds, again, my shape would be linear. Last example, almost for fun, I wanted to throw in a polyatomic ion. So remember the 6 I asked you to memorize? This was one of them. This is the ammonium ion. All right? Now, when we're dealing with polyatomic ions and trying to draw their structure, we got to remember when you gain electrons, right, you become negatively charged, and when you lose electrons, you become positively charged. So if I have a positively charged ion, that means I need to subtract the electron off the total. If I have a negatively charged ion, I need to add that electron to my total of valence electrons when I'm trying to figure out my structure. So in this case, nitrogen has, of course, if we look on our table, it has 5 valence electrons. Hydrogen has 1 valence electron, but there's 4 of them, so that's 4. So it looks like I'll have 9 electrons here, but wait, there's a positive charge there. So that means I lost an electron, so I have to subtract 1 off my total. So if I add that up, I get 8 electrons, okay? If I draw my Lewis dot structure for nitrogen, you can see that I would get 5 electrons. I have makes 3 bonds, whereas of course hydrogen is only going to make 1 bond because it only has 1 valence electron. How is it going to work? Maybe you're getting better at this. That's going to share there. You can see that happening, and then it's going to happen on all other sides. So my final structure for the ammonium ion would look like this. That's the side that we did, and then we just fill in the rest like that. Notice how the nitrogen clearly has 8. Not even going to draw that in right now. And then the hydrogen has 2. So I've done my job, and again, my total electrons was supposed to be 8. I get it. The last thing I was supposed to do was just bracket this off and indicate that it had a positive charge. We didn't do this one in the lab, but if you were to make this, this would be the ammonium ion, and it would have 4 single bonds, so it's a tetrahedral shape. Okay? So I'm hoping that was a little bit of help. Again, I'll see you in class next time. Have a great day.